Hello everyone, it's Mr. Hurd. This Thursday we're going to be talking about yeast and the chemical reactions it creates when we are creating pizza dough. Woohoo! It's going to be Thursday at 3:30, so go to Schoology and look for the link that says Mr. Hurd's Fun Science Class. Click on it and bring some food and drinks while you're entertained. I've never made pizza dough before, so it should be interesting. Once again, 3:30. All right, go to Schoology and you'll see the link. What I'm going to do very briefly today is talk about what we did last week. So what we talked about last week was air pressure. We talked about what air was. It's about 78% nitrogen, 21% oxygen, and air has matter, something that takes up space. It has volume. And it also has mass. Air can be weighed. And even though it's invisible, it really doesn't seem to have either one of those things. So we talked about air pressure with altitudes. Seattle is at the bottom of ocean air, whereas Denver, which they call the Mile High City, Denver is actually 1 mile above sea level. Okay, we looked at those two cities. And we just compared the air pressure to both of those cities. In Seattle, on average, there's about 14.7 pounds of air pressure pressing down on our heads. And in Denver, there's about 12.7 pounds of air pressure pressing down on them all of the time. So the air pressure is greater near the ground than it is higher in the sky. And we used a stack of books to illustrate that to you. The weight or the pressure on the bottom book would be much greater than the pressure on the top one, as you can see over there on the left-hand side of the screen. It is the same with air molecules. The molecules on the bottom have a greater pressure on them than those above. If you ever climbed a mountain, you could probably feel the air pressure. Your ears will pop in order to balance the pressure between the inside and the outside of your ear. So our first experiment contained a candle, a jar, some water with food coloring. And what we did was we lit the candle, and then we took the jar and we placed it on top of the candle all the way down to the water. Eventually, the candle went out. And then what happened was the water that's inside of the jar started to rise. And we talked about why that happened. Well, what happens is the candle warms the air inside of the jar. Now the air expands because the air is warm and some of it escapes. When the flame goes out, the air cools down, which means there's lower air pressure. Then the air pressure that's outside of the jar is a little bit heavier, and it presses down on the water that's outside of the jar, causing the water to rise inside of the jar. And the reason it does that is because it's trying to balance the pressure. See, nature wants the outside air and the inside air pressure to be balanced. And so the air will press down on that water until that pressure is equalized on the inside of the jar. We also worked with soda cans. And what we did with soda cans is we filled it up with a few drops of water. And then we heated up the can until steam was coming from the inside of the can. We took that can, we turned it upside down, and then placed it inside of cold water, and in a split second, that can imploded, right? It shriveled up like a raisin. We talked about imploding, as you can see on the screen there. It means the sudden collapsing of an object towards its center. So it's kind of the opposite of an explosion where everything blows up and away. Imploding means it collapses towards the center. And so when the can was turned upside down and placed in the water, what happened? It created an airtight seal. Now remember, when we were heating up the can, the water molecules were pushing air outside of the can, which means less air inside of the can. And so we turned it up. Once there was an airtight seal, it just shriveled up because the outside air wanted to create a balance between what's on the outside and the inside of the can. And that's why it shriveled up so suddenly. So while we were doing these experiments, I was drinking from a straw because I wanted to illustrate just another way of looking at air pressure. Usually, when we talk about drinking from a straw, we really think of sucking liquid into our mouth, right? But that's really not quite, scientifically speaking, that's not really what's happening. What's really happening is that the outside air pressure is pushing down on the surface of the liquid. When you reduce the pressure in your mouth, so with that sucking action from your mouth, the outside pressure is greater than the pressure that's inside of your mouth and inside of the straw, and therefore the outside pressure is greater than the pressure that's inside, and it forces the liquid to rise up into the straw. It's kind of a weird way to think about drinking. And so that's just another way that we looked at air pressure while drinking with a straw. So that's what we did. It was a lot of fun. Some of the takeaways is that there's more air pressure at sea level. Warm air means that there's higher air pressure. Cold air means there's lower air pressure. We learned what imploding was. And we also learned that air works with nature to create balance. We talked about balance and how air pressure, outside of a can is trying to balance inside of the can or inside of the jar or inside of the straw and outside of the straw. It's all about balance when it comes to air pressure. So that's it. I hope to see you Thursday. Bring food, bring drinks, and we'll do our best to try to create some pizza dough.